welcome to video 7 for our factoring series in lesson 5-3. In our last video, we took a look at what was happening when we were missing a C value. In this video, we're going to take a look at what happens when we're missing a B value. So we're going to go ahead and take a look at the example. Negative 2x squared plus 98 is equal to y. Remember, the first thing we want to do is always set this equal to 0. And then the very second thing that we're going to want to do is check for a GCF. In this case, both of these numbers are even numbers, so we know that we can pull out a 2. And we also don't like having a negative in front of our x squared term, so we're going to go ahead and pull out a negative 2 from this. And when we factor that out, it's going to leave us with a negative 2 times x squared minus 49. Now we have a little bit of a reminder here on the side. Remember, whenever you factor out a negative 1 in an early step, you have to make sure that you carry it through the rest of the process. So every step after this needs to have that negative that we pulled out from the negative 2. So as we keep going, we are seeing that we have no b value. We have the x squared term and we have the constant term, but we don't have a term that just has the x. So what that's going to mean is, just like in the last video where we let c equal 0, this time we're going to let b equal 0. So we're going to rewrite this as negative 2 times the quantity of x squared plus 0x minus 49. Now we are going to go ahead and lock in our x's. If you remember from the last two videos, when we have an x squared in the front and there's no coefficient in front of it, that just is going to mean that we're going to have an x and an x at the beginning of the parentheses. Now we need to look at whether our signs should be the same or different. In this situation, we are going to have a situation where they are going to need to be different, because to be able to multiply to get a negative number, we have to multiply a positive times a negative. Now we are going to go ahead and fill it in, a plus and a minus. It really doesn't necessarily matter if you put the plus in the front set of parentheses or the minus in this first set, as long as you have one of each. Now here's where we again have to do some critical thinking. We want to know what is going to add together to give us 0 and multiply to equal negative 49. Now the only way that we can add two numbers together and get 0 is for them to be opposites. One's going to have to be a positive of the same number as the other one is negative. So we want to know what numbers are opposite, that means they're the same number with opposite signs, and multiply together to equal 49. Now if you remember, 49 is a perfect square, and the perfect square of 49 is 7. So we're going to plug in a positive 7 and a negative 7 into this, and then we're going to multiply out to make sure that this works. So when we multiply the 7 times the x, that is going to give us 7x. And when we multiply the x times the negative 7, that is going to give us negative 7x. And when we add those together, that is going to give us 0x. So we have this all set up. We have it factored. We figured out our middle term was 0x, just like it was supposed to be up here. Our last step is to set each of these equal to 0. So we're going to do x plus 7 equals 0, and x minus 7 equals 0. Now, we would have on the other side, we would also set negative 2 equal to 0, because we have that coefficient there. But negative 2 is never going to be equal to 0, so that's going to mean that that one is no solution. So it's not going to be one of our answer sets. So we'll focus on the ones that will be our real answers. So we would subtract 7 from this side, and we would get x equals negative 7. And on this one, we would add 7 and get a positive x equals 7. Now, you can write the answer like this. Sometimes on a multiple choice test, you may see this written as plus or minus 7. That just means that it's going to be an answer of 7, and it's both a positive and a negative form. This is probably the way we'll write it the most frequently, but just in case you're on one of those multiple choice tests and you see it written out like this, then you know that these are the two same things. Alright, so we will see that this actually does lead to a pattern. If you notice at our first example, and I'm going to rewrite this out just a little bit off to the side here, we had negative 2 and we had x squared minus 49. Now if you look at these, both of these terms, our x squared and our 49, are going to be perfect squares. My x breaks down into x, and those are the same things multiplied together to give us the first term. And then our second one is also a perfect square. If we multiplied 7 times 7, that gives us 49. We do have this pattern off to the right that you see in your text box over here that will be a way that you can do this a little bit easier using this property. All we're going to do in using that property, you can see the pattern here, is whatever the perfect square of a squared is, we would put a and a, whatever it was in the front. In this case, it was x and x. And then for the second one, you would put the square root of the perfect square for b. So in this case, 7 and 7. And you would just want to make sure that one's a positive and one's a negative. And we talked before how it doesn't matter which is which. Now, that's just a little trick and a little technique. You don't have to use that. We still want to encourage you to use the same factoring process we've used all the way through that we've been doing in these example boxes over here. But that is something that you can look on to see if you can maybe save a little bit of time if you do recognize that pattern and you do pick up on it right away. Now, occasionally we may run into a quadratic equation that is not going to be factorable. So let's take a look at what this might look like. So let's, for example, try 3x squared minus 7x is equal to 12. The first thing we're going to want to do is to set this equal to 0. So let's go ahead and do that. Then the next thing we're going to want to do is to set up our parentheses. Now, 3x squared, the 3 is going to be prime, so that means we can go ahead and lock in the 3x and lock in the x, and those aren't going to change. And then the next thing we need to do is to look at our signs. So if I'm looking at my signs, I have a positive 12 and I have a negative 7. So to be able to get a positive 12, I have to multiply these same signs together. They either have to be both positive or they have to be both negative. Now the fact that the b term is going to be a negative 7, that is going to tell me that I want the double negatives here. So I'm going to have a minus and a minus. So the next thing that we're going to look at is we're going to look at the factors of 12. We could have a 1 and a 12, a 2 and a 6, and a 3 and a 4. Now remember, we talked about how we can't have a GCF within these. So 2 and 6 have a GCF, so we're not going to want to use 2 and 6. So that narrows it down to 1 and 12 and 3 and 4. So remember, we want to start out with the ones that are closest together. So let's go ahead and try the 3 and the 4. Now, we'll go ahead and plug this in and do some guessing and checking. We can do 3x minus 3 and 3x minus 4. When we multiply these together, we're going to get a negative 9x and a negative 12x, and that's going to give us negative 21x, which is not what we have in the middle, so we know that this is not going to work. Let's just try to make sure, since 3 and 4 are so close together, let's just try switching that around. So let's put the minus 4 in with the 3 there, and put the minus 3 in with the x. When we multiply these together, it's going to give us negative 4x and negative 9x, which is going to be negative 13x, which is still not going to work. So we can see that we've tried both of these two, and they're not going to work. So that means we are going to need to try 1 and 12. Now, it's unlikely that these are going to work, but we always want to double check to be sure before we go ahead and say that these are non-factorable. So I am going to plug in 3x. We know we want a negative 7x, so we probably don't want that 12 with the 3. So we're going to put him in here. And then we would go ahead and plug in the x minus 1. Oops, don't want to make me any larger there. We can shrink that up so we have room to do this problem. Okay, he's not going away. There we go. So we are going to do x minus 1. Let me get my pen back. Sorry there. Alright, when we multiply these out, we're going to get negative 12x, and we're going to get negative 3x. That's going to give us 15x with a negative. That's definitely not going to work, and it's very unlikely that this is going to work, but I'm just going to go ahead and show you guys so that we do have this on record. But we'll go ahead and do 3x minus 1 and x minus 12. 3x times negative 12 is going to be negative 36x, and the negative 1 times the x is going to be negative x. That's going to give us negative 37x. So we can see that neither combination of these work. Now, before you go ahead and say that this is not factorable, you do want to go ahead and make sure that you have really checked all your options before you jump to this conclusion. A lot of times people will want to just check a couple and they'll just assume that it doesn't work. They may have some that they didn't think of as far as things that would multiply together to give you that last number, but just make sure you do a thorough job checking before you jump to this conclusion. So we can't really do anything with this for now. We will pick up a strategy in Unit 6 that will help us deal with these problems that are not factorable, but for now we're just going to have to leave our answer as not factorable. Alright, there are some U-tries after this video. Make sure that you guys go ahead and do your best on those, and then come back for one last video 8 to wrap up this long lesson. Alright, see you guys there.